It's time to now look at the solutions for the two assignments that we've seen. So let's get started and look at the solutions. So the first assignment is about stickiness. The intention of the stickiness assignment was to ensure that we figure out whether we are losing loyal customers or not. So the problem was that looks like we are kind of losing our loyal customers, and what we wanted is on a monthly basis what or how customers have been visiting. If we carefully look at it, the intention of the stickiness project was something like this. It was this is precisely the goal that we had in mind. So the stickiness project was all about finding how customers have been visiting over the months, and this is what will give us that. So how do we go about it? Now, normally students would take three approaches or three different solutions to this. Let's look at all three approaches and then we see which is the best one or which is the most optimal one. So let's start by looking at each one of them. So we have our data that looks like IP, page, date, browser, and the load time. So what we are going to do here is we will first so here we are majorly interested in the timestamp and the IP address. So let's see what approaches we would end up taking. In the map phase, we will read the record and tokenize it. After we tokenize, what we would emit is IP comma month hash year. Now that's the first approach that normally students would take. They would have key, or typically one of you might have in the problems solved it in such a way that you have IP as your key and the month hash year as the value. And in the reduce phase, what you get is IP comma in here in the reducer. What we would do is, now that we have IP, we will read the values and we would read out the values and figure out the occurrences of same month hyphen or hash year. So something like we found 96 Jan hash 2014 and 80 Feb hash 2014, and that would mean 1 by 1 we limit and so on and so forth. So what we decide is we will have key as IP address, and what comes to the reducer is IP comma month year month year month year, those many number of combinations. Now what we are interested in is finding how many combinations were there for Jan 2014, and let's say we find 96. What that means is user visited our website 96 times in January, 80 times in February, and so on and so forth. So the first approach a lot of times students would take is doing it by IP address. And if you see, the reducer has a lot of work to do because you have so many values. First you break them into month hash year combination and then count them for each one of them and emit them one by one. So it's a lot of work that you're doing in solution number 1. And let's just say that the amount of work that you're doing in the reducer makes it not so friendly. So this is one way of doing things. Let's put this, or let's document this approach, and then we'll see solution number 2. So the first thing we do is we tokenize, we extract IP address. So the reducer, what we'll see is we'll end up seeing something like so that's our key. And so on and so forth. So IP address 192.168.1.1 came to our website and we saw these are the number of requests, and each request consists of month and year. So let's iterate through the elements. So let's say here we'll have a variable feb plus plus. We'll continue incrementing this. Whenever we have March, we'll increment this. So what you would end up getting is so this is how probable output would look like. So what we've seen is that if you take this approach, a reducer is going to do a lot of heavy lifting. It gets all the requests, and then based on the month and year combination, it will basically go about figuring out what should be done. So this approach is great, but will have a lot of work to be done in the reducer. Now let's look at what other approach could be taken. A lot of times this approach may sound legitimate, where you have maybe a month, an IP hash year can be a possibility, or even this is a possibility. So if you decide to have month, this is another possibility where you have a month and year combination, and you'll have IP addresses, IP1, IP2, IP1 again, IP2 again, and so on and so forth. So here the combination of month and year is taken as the key. What happens here is we read all the values and we figure out the same IP address. So let's say we found 96 occurrences of So we'll have values coming out based on month and year. So this is second approach, where again we see that the reducer has to do good amount of work. Either you have key as month or month hash year, and you have IP addresses as the value. And for each month and year combination, you'll have multiple IP addresses. You'll have to figure out the same IP addresses and then count them. Once we count them, we figure out the number of requests that were made for each and every month and year combination. In this also, we see a lot of work has to be done, or a lot of heavy lifting has to be done by the reducer. So let's look at, let's document this to understand this further. So here we'll extract month and year, and month and year becomes a combination, and IP would be the output. So here we see that, let's say there are 3 requests from 1.1, that's our input. We'll iterate through the list, and based on each and every element, we will bifurcate the list or the variable based on the IP address. So if IP is then we increment so you get everything by month and year. Again, in this case, we see it's kind of very equal to what you would do in first case, and reducer will have to do a lot of work. Now let's look at the ideal approach that you should be taking, and we will then compare all the 3 approaches. The ideal approach that should have been taken is we should have had a key which is IP month year, 1, and reducer will simply IP month year, and let's say 5. So this approach, we are using a composite key IP month year, and along with that we are having 1 as the count, and we add everything up in the reducer and we simply get the output. Let's understand this in the document and we'll compare all the 3 approaches. So that's our key. Add all the values and what you get is So what you see is that the third approach is the most optimal approach because you are using the benefit of or you're taking the benefit of the partitioner. Now the way partitioner works is it partitions based on the key. Now instead of first partitioning by IP or month year and then later on iterating through the list, why don't we directly partition based on the key that we really want? In case we do that, we are then utilizing the benefit of the partitioner, and in the reducer you are simply adding everything up. Now on a large cluster, this can give you a massive performance. Some tests have shown that, for example, for 100 terabytes of data on a 400 node cluster, when we performed a test with this partitioner, what we realize is that it takes 6 hours for us to do it with approach 1 and 2, and with approach number 3 we can do this in around 3.5 hours. The point is we are utilizing the partitioner properly. We are partitioning based on the key properly. So the learning here is if you convert things to a SQL query, whatever is your group by clause, whatever happens to be your group by clause, just make that as your key of your Mapreduce program. You will never go wrong with the performance of the program. Let's compare these 3 approaches in a single slide, and then we move to assignment number 2. So let's say there are 3 or 4 possibilities. Let's write down all the 4. In solution 1, my map will emit IP, month hash year. And in the reduce side, we will first so in this case our input would look like so for each IP address we are going to basically break all the values based on month hash year and then count the occurrences. So here we break all the values based on month hash year and we see that there are 2 Jan 2014s. So we'll add both of them and emit this IP came in Jan 2014 2 times to us. And here we see that the reduce has to do a lot of work. So solution 2, let's take exactly same thing. But what if we just put month here and IP hash here? Nothing really changes, it just remains the same. We break all the values based on IP hash here and we get the values. Again, it's exactly same, and again reducer will have to do a lot of work. Solution 3 might be, what if we put year here, which is again legitimate. So for each month and year combination, we'll have a lot of IP addresses. Here we'll break all the values based on IP address, increment each value for IP address and then emit the value. Again, not very smart. So that's, let's just say solution 3. And now let's look at if we put it this way, that's it. So here we are utilizing the benefit of a partitioner because partitions based on the key. In the beginning itself, we are having a composite key for IP month year, and based on that, the data would get bifurcated. And this is where the reducer will be really lightweight and you will be utilizing your cluster in a better way. This is how we will go about solving our problem number 1. And this solution is the most optimal one. So the trick here is this is the real moral of this particular story. This is the real moral of this particular story, and that's assignment number 1. Now let's look at assignment number 2. Assignment number 2 is exactly same as the average problem that we've seen in the previous case, so it's no different. So let's directly document it with the combiner. So it's format battle. So we'll first tokenize, we will extract the extension of the file. In this case it is HTML. So what we'll emit is HTML 856. So that's our output. Now the key being HTML, because here it's a format battle. We are interested in the format, that is HTML, JPG, and so on and so forth. So here we are interested in the formats. We'll have the combiner. And what we do is we simply perform the sum. Why only sum? Why not average? We've already discussed this in length in the Microsoft example in the previous video. So that's, let's say 2606. And let's say 3000. We'll extract all the values, we'll extract all the counts, and what we get is 5606. divide by 6, and this will be the load time for HTML. This will be the load time for HTML. So what we've seen in this particular case is this particular assignment is exactly same as the previous Microsoft average example. Here what we are doing is in Mapper we are extracting the extension of the file and the load time, because here we are supposed to figure out the average load time for each and every format. So what we do is we tokenize it, we extract the extension and the load time, and from our mapper we are emitting extension comma load time. So let's say the output is HTML comma 856 milliseconds. In the combiner we are simply adding all the values. We cannot perform average directly in the combiner, because if the denominator changes we are going to be in big trouble. That is why we simply add all the values and we get the count. So let's say in combiner 1 what we get is 2606, that is 856 plus 900 plus 850 milliseconds. So it's 2606 milliseconds, and the count is 3. So because there were 3 HTML requests. In the reducer what we get is HTML 2606 hash 4, and let's say, or hash 3 for that matter. And what we get is, let's say from another combiner we get 3000 hash 2. In the reducer process we will first take all the values and we'll tokenize them again based on hash. So we get 2606 plus 3000, that's 5606, and 3 plus 2 is 5. We perform average, and whatever our output or average load time, it will be HTML comma 5606 divided by 5. That will be the load time for HTML format. The same process will apply for, let's say, JPEG, PNG, and so on and so forth, and that will be our final output. So this is how we go about solving our both the assignments. A quick iteration. So the assignment was, we have a bank, let's say, or any institute or any enterprise that's losing out its customers on the website front. What they do is they hire a new director for web operations. The director starts 15 new initiatives in the organization, and we are interested in 2. The first one was stickiness. In the stickiness assignment, what we were trying to figure out is by month how many times a single particular user has been coming, to see what has been his trend or each user's trend in coming to the website. That was nothing but a glorified group by IP month year query. Now there could be multiple approaches to solve it. The best approach to solve this will be having a composite key as key, that is IP month year, and passing the count. In the reduce you add everything up, and what you get is from a particular IP in a particular month and year, how many times the user came for that particular month. That way we will get the number of requests. So that was stickiness. Now this output could have been then fed to a reporting tool, and reporting tool would have visualized the whole thing. The second assignment was format battle, where we were interested in finding out the average load time for each and every format. How much time does each and every format take to load on an average? So what we do is we simply extract the format, we extract the load time in the mapper. We decided to optimize it by putting a combiner, but average cannot be performed in the combiner. So what we do is we simply go ahead and perform addition in the combiner. Along with that we pass the key. And in the reducer, what we do is we simply take addition of all the load times and addition of all the counts, that is number of requests. And finally, total load time divided by total number of requests ends up giving us the average load time for this particular or each and every file format. That is how we get our stuff done. This is how you go about doing this assignment. So far what we've seen, we've taken 2 assignments on Mapreduce with an intention to explain how to go about designing Mapreduce programs. In the first set of assignments, we saw how to put a combiner, partitioner, and in the second one, we just majorly saw what's the importance of having or deciding your key properly and how it can improve your performance. So this was about the 2 assignments. In the next videos or in the remainder of videos in this course, we will look at advanced Mapreduce concepts. We'll look at input splits and compressions. We'll look at joins, use cases of Hadoop or use cases of Mapreduce. We'll look at how do you go about extending Pig Hive and using it with ETL tool. So let's see you in the next videos.